So we were doing now ideal diode model. Okay. Am I audible?
Yes, sir.
So let us do one problem. So whatever we have learned now, that we have to utilize here. Okay. 10 volt is given. Here resistance is given. Here one resistance is given. So this is 4 ohm, 4 ohm, and then you have a diode here, and then you have a 1 ohm resistance here, and then you have a 1 milliampere current source. 1 milliampere, 2 milliampere, 2 milliampere current source. Okay, and the resistance value, this is 1 ohm. And you need to find current flowing through the diode. Okay, and it is assumed the diode is ideal given. Okay, diode is ideal, and you know what is the meaning of ideal. If it's forward bias, it is short circuit. If it is reverse bias, it is an open circuit. Okay, so we have to find first whether it is a forward bias or reverse bias. For that, you know what we supposed to do. Tell me what I supposed to do. Okay, so first step, remove the diode. Very good. Okay, so step first. Okay, find the biasing. Find diode. Find whether diode is forward bias or reverse bias. Okay, open this one. Okay, now by opening this one, I know if this current flows here, here the voltage will be 2 volt, and this 10 volt, if you divide this between, the current will come here, no current will go from here. So if I say here it will be 5 volts and here it will be 2 volts. Okay, so 5 minus 3, 5 minus 3, 5 minus 2, 3 volt. Okay, so basically it is a forward bias. Okay, directly you can replace by short circuit, or either what you can do, you can make a V Thevenin circuit. Okay, so in order to make a Thevenin circuit, you have to find the V open here. So V open will be 10, current is coming 10, 10. Okay, so here it will be 5 volts. Okay, so this is a plus 5 volt, and here this current cannot go here, current will go here. So here it will be 2 volts. Okay, so V open, V Thevenin will be 5 minus 3, that is 5 minus 2, 3 volt. Okay, now next thing is you have to find the R Thevenin. So for R Thevenin, you have to make this short circuit, and you have to make this open circuit, current source is open. Okay, now these two resistances are in parallel. 4 is parallel. Okay, and the combination now this parallel, let's give you 2, how much give you? 4 into 4, 4 into 4 upon 8, and plus again this 1 ohm, 1 ohm, 1 ohm. So this will give you 1, 2, 2. Total is giving 3 ohm. Okay, so since so simplified circuit will be what? You will be having V Thevenin. Okay, that is 3 volt, and then you put a R Thevenin of 3 ohm, and then you can keep a diode here, open circuit diode here. Okay, you can keep diode here. So basically this is your circuit now. Okay, now this diode is forward bias, so you can replace this diode by a short circuit. Okay, so now you can find what is current flowing ID. So ID with the circuit will be, ID will be 3 volt, so parallel to 3 ohm, divided by
1 ampere.
1 ampere, and 1 ampere answer. So it is very easy. Diode circuits are very easy. Okay. Very little chances there that a complicated circuit will come. And if it comes, I will tell you how to do that circuit also. So in this way, ideal diode model is done. Okay, you have to replace by short circuit. If it's forward bias, if it is reverse bias, you have to make it open. Okay. So now let us do some properties of diode like rectifier. Okay. So first we'll start with the half wave rectifier. So let us do now half wave rectifier. I'm erasing this one. Okay. So here's this one. But now we'll do applications one by one. Okay. First is your half wave rectifier. Half wave rectifier means you have a this diode. Okay. Here you have a load resistance RL, and here I'm applying a sine input. Okay. V input, say that is Vm sine omega t. Sinusoidal input I'm applying. Okay. So that means now my input, I know what is my input. My input is a sinusoidal wave. Okay, it's my V input, this is my Vm. Okay, and now I want to find V output here. Okay, my digital meter, or my meter is putting like this. I'm measuring voltmeter voltage like this. Okay, this is my ground. Now let us see what happens when now for positive cycle, for positive cycle. Okay, this it is a positive cycle, this is a negative cycle. Okay, so when you're applying a positive cycle, okay, this voltage is positive. Okay, this is the ground. So here positive voltage is applied, and because the ideal diode, so for positive cycle diode is forward bias. If a positive cycle diode is forward bias, then we can replace it by a what? We can replace it by a
Short circuit.
short circuit here, and this is your RL coming here. You're coming here, you're measuring V output here. This is your V input is coming. Okay. So for positive cycle, what will happen? There will be no drop across the diode. So all the voltage will come here. Okay. Suppose this is the 5 volt maximum. If you're applying 1 volt, 1 volt will come here. If you apply 2 volt, 2 will come 3, 3 come 4, 4 come 4, 5 come 5. Because there is a no drop here. Okay. VD is 0. So your V output will be exactly equal to V input for positive cycle. For positive cycle, V output will be exactly equals to V input. So you get exactly like V output will be exactly like your V input. Okay. Now tell me what happens in the negative cycle. Okay. This is the positive cycle. Now next, when you apply negative cycle, now you have to understand what is the meaning of negative cycle. Negative cycle का मतलब क्या है? Whenever I say positive cycle, that means this part is positive cycle, this part is positive, this is negative. So current will flow like this. Okay. And when I say negative cycle means the polarity is changed. Polarity changing. This is a positive, this is a plus, this is a minus. Next time this will be plus, this will be minus. Negative cycle. So if a current flows in the circuit, direction will be up like this. Okay, but first we have to see whether it flows or not. Okay. Now for negative cycle, what will happen? For negative cycle, okay, diode is forward bias or reverse bias?
Reverse
Reverse
bias.
bias.
because this point is positive, negative, this negative, and this is coming positive here. So this voltage is a diode is reverse bias. So you can replace this by a now a open
Open circuit.
open circuit. So how much current is flowing in the circuit?
0.
0. Okay, that is now current in the circuit is 0. That is ID flowing in the circuit is 0. Diode through diode, and of course the current which flows in the load. Okay, IL also 0. Load current 0. So if there no 0 current, the output will be 0. Okay, so for negative cycle, okay, the UV output will be 0. So you get here 0 for this cycle. You got 0. So because it's allowing, because the diode is unidirectional, it allows the current flow only in one direction. Okay, and because in a circuit we are taking output as a given, so you are getting only output for positive cycle. Okay, so this is like a only you're getting negative part you're getting, so you're getting only positive one side current. Okay, so that is and usually using only half wave, so this is called half wave rectifier. Okay, now I want to find the average voltage here. Average voltage, how much average voltage I'm getting, okay, for this part. Okay, so what is the formula for average voltage? So average voltage in a circuit, average of any function given how much for a time period, a time varying function. Okay, it is given by 0 to t ft dt. Okay, because it's a sinusoidal time period periodic functions, and periodic function you can know, you can find the average like this. So if I want to find the average voltage, okay, because here current is getting varying, so average voltage I have to find. So what will happen, I will write, okay, so first of all I have to write how much voltage I'm getting. So I'm getting voltage equals to Vm sine omega t in the time period of 0 to 0 to t by 2 time only. Okay, for this period only, this is t by 2. Okay, full cycle, half cycle. So here I'm getting a output only for t by 2 time. Remaining period I'm getting 0 output. Okay, so t by 2 t I'm getting 0 output. Okay, you can put here and you can find the average value and get me the answer. So now let us look how to find the average value. So V average will be your 1 by t 0 to t by 2. Okay, ft dt, that is Vm sine omega t dt, and then remaining part for average you have to take full one. Okay, if you want to take only t by 2, then you have to put t by 2 here. Okay, I'm taking full cycle t by 2 t, and I'm getting 0 here. So basically this will give me 1 by t. Okay, you can solve this integration, simple integration. This will give you what? Vm sine omega t give you cos omega t, and omega t will come down. The limit is 0 to t by 2, and of course this part becomes 0, so I don't need to worry about this one.
नेगेटिव आएगा ना साइन इंटीग्रेशन ऑफ साइन नेगेटिव कोस ओमेगा टी होता है
minus cos omega t. Okay, so now you can change the limits. Okay, so Vm, so I can put Vm outside, okay, and omega also I can take out, and this become now cos omega t, that is cos omega t. I can write cos 2 pi by t into t omega value. Okay, omega value I can put here. Here also you can put, and the limit I can write now 0 to t by 2, because I observe the minus here. So this is Vm 2 pi by t into t cancel out, and if you put 0 here, this become 1. If you put t by 2 here, t by 2, how much become pi, cos pi. Cos pi is how much? Plus
-1 -1
minus minus 1. So this minus minus become plus. So now if I find V average, so this will become Vm 2 pi, and this is minus minus 2, so it will become Vm upon pi. So this is your average value of voltage for half wave rectifier. Okay. Now here we have seen the output. Okay, my output was, I was measuring the output. Okay, and you can see the output wave out. So you're taking average only of output, and output was like this. Output was like this. The output. So I wrote output like this. Pm sine omega t. Okay, 0 to t by 2. Okay, and I wrote 0 for t by 2 to t. Okay, now say suppose I get output instead of this one, I get output like this. Then what should I write here?
-Bm sin omega t.
Tell me, minus or plus? माइनस और प्लस?
माइनस।
अरे भाई ये तो एक ही फंक्शन है, इसको साइन चेंज क्यों करोगे? ये तो साइन ओमेगा टी है.
सर क्वेश्चन कहता है क्लियर, एक बार फिर से बताओ.
आई एम सेइंग इफ यू वांट टू राइट, इफ आई वांट टू राइट दिस वेव इन द फॉर्म ऑफ इक्वेशन, व्हाट शुड आई राइट हियर? वेट, ये तो दिस इज साइन वेव ना?
सेम ओनली सर।
सेम ही होगा ना?
Vm sin omega.
तो आई कैन डायरेक्टली राइट लाइक दिस ना.
ओके, मैं सोचा था हाफ, आप लोअर हाफ के लिए बोल रहे हो. आई वाज थिंकिंग दैट.
तो लोअर हाफ भी साइन ही है, लोअर हाफ भी साइन ही है, बिकॉज साइन इज इन दिस इंटरवल. ओके, इन दिस
हाँ, यस सर.
sign is negative. Okay, if everything is greater than pi, third quadrant sign is negative.
यस सर, यस सर. या
So no need to put negative sign, it automatically negative only. Okay,
या
so this I can write like this also. Both are same thing. Okay, I can write like this also, t by 2 t and t. That's both same thing because same function is using. Okay,
यस सर.
and average of sine wave is 0. You know, if you solve this one, average of sine wave becomes 0. Okay, now suppose instead of this one I get my output is like this, then what should I write here? So this is your sine wave up to t by 2 or up to pi. This is perfectly fine. Okay, for this one what should I write? For this part what should I write? This is a minus or plus?
सर साइन स्क्वायर.
ये स्क्वायर का है तो exactly
माइनस ऑफ दैट वी नो।
yes, minus of Vm sin omega t, t by 2 t by 2. So whatever sign values you're getting which will come negative, if you put minus sign, that part become positive.
यस सर. या
So whenever you get the output like this, you have to write the equations, because if you want to find the average, you have to write the equations in the form, the function in the form of equations. Okay, so if you're getting like this, you have to put minus here because sign already has is this period is minus. So minus minus will become positive, this will become positive. Okay, that you have to keep in mind. Is that point is clear or not? Tell me, very, very important point. Is there any student?
क्लियर सर, क्लियर सर.
Okay. Or the student Palak, Sir Pandika. Is that point clear?
Clear, sir.
सर एक बार फिर से बता दीजिए सर, ये प्लस और माइनस.
भाई अगर ये ऐसा वेव ऐसा है तो ये साइन वेव ही है, क्योंकि ऑटोमेटिकली इस पीरियड में हमको नेगेटिव चाहिए. साइन ओमेगा टी नेगेटिव होता ही है इस पीरियड में, पाई टू 3 पाई बाई 2. दिस इज व्हाट, पाई टू 3 पाई बाई 2. ओके, ये तो होता ही इसके बीच में तो हाँ, इसके ये क्या मैंने यहाँ से t बाई 2 टू टी. हाँ, इस पीरियड में तो इस पीरियड में तो ये साइन नेगेटिव होता ही है, ये ऑटोमेटिकली आपको नेगेटिव मिलेगा. आपको नेगेटिव लेने की जरूरत क्या है? ये तो नेगेटिव साइन पूरा फंक्शन, ये पूरा फंक्शन तो साइन ही है. बट अगर फंक्शन इसकी जगह हमको आउटपुट में ऐसा मिलता है, then this part is sign exactly like a sign, but this is not sign. This is the opposite of sign. So you have to put minus here. Okay. So you can do if I make this one for this one, this is the equations that point you remember. Okay. Because sign automatically comes negative. So that part you have to keep in mind, that angle. Now, if you understand this one, so you can solve all the rectifier and half rectifier problems. So let me give you now full wave rectifier. Full wave rectifier. So full wave rectifier. This diode. And then you have RA. And I have here put one more diode. Here one more diode. So this is my circuit. Okay, this is my circuit. And now I want to apply input. Let me apply. Applying input here. I am applying a V input equal to Vm sine omega t between these two terminals. And now I have to measure the voltage. A voltage where I'm measuring, that is my choice. Huh? Where I want, wherever I want, I can take the output. So let me take, I am taking the output here. I'm measuring my output like this. Okay. Now let us see how this circuit behaves. Okay. How this circuit behaves for this given input. Okay. So let us take for positive cycle. For positive cycle, you can, if you want, you can give the name also. Say this is my D1, this is my D2, this is my D3, and this is my D4. And diodes are ideal diode. So now let us say for positive cycle. For positive cycle, what will become for positive cycle? For positive cycle, my V input is Vm sine omega t. V input is zero tiny. Okay, only I know this positive. So for positive cycle, this part become positive and this part become negative. Okay. So tell me which diode is forward bias, which is reverse bias. Okay.
D1 is forward biased.
Forward
D1 and
bias.
D3 is forward biased.
D1 is D1 and
D3 is
D1
forward.
and D3 in forward
minus
biased.
minus D3 is forward bias. Okay. So D1 and D3 are forward bias. Are forward bias. Okay. Here is a positive, here negative, negative. Yeah, they are bias. Okay. So you replace this by short circuit. So I have replaced by short circuit. Okay. And this is reverse bias. Okay. I am using voltage. Let's see. Here this is, and here this is a open circuit. This is also open circuit. Everybody is comfortable with this one? Okay. Now my current for positive cycle, current come like this, current will come like this. Okay, current cannot go here, so current has to come here. So I'm getting a V output like this in this direction. Okay, then current cannot go here, current can come here, current can come here, and current can come here. My circuit is completed. Okay, I go, and because here no drop is there, so whatever voltage here is same voltage come here. Okay, so my V output is exactly equal to V sin omega t. So my V output is what? Equal to Vm sin omega t for positive cycle. Positive cycle means for 0 to t by 2. Okay, clear? Now I am putting the next period. Next period, my current is coming how? Tell me. My current is coming now here, from here, this side. Okay, for negative cycle, negative cycle, or negative cycle. Okay. Now negative cycle, diode. Which diode is positive? This is the open circuit. This is the forward bias. This is the forward bias, and this is the forward bias, and this become a reverse bias. So diode D2 and D4 are forward, D2 and D4 are forward bias. Okay. Now current will come like this. Negative cycle current will come like this. This is positive. Current will do this become short circuit. Again, here current cannot go. Current again will come here only, and then current will go here. Short circuit and come here. Circuit is completed. Okay. Now I get V naught. Okay. So what should I write? Plus or minus? Plus or minus?
सर सेम ही है, डायरेक्शन सेम है.
Direction to same hai. Okay. Okay, very good. Direction is same. That means
लोड में सेम आ रहा है डायरेक्शन.
direction same hai. So if you are get load with direction same hai, so you are getting sine wave here. Okay. And your V output is like this. V output is exactly like this. The same direction is coming, same direction. So it's not going down. Negative, you're not getting negative. So now, if I want to write the functional form, what would I write here? Minus or plus? Obviously, I just told you if you want to express this one.
With minus sign, रिवर्ट कर रहे हैं.
Minus 7 because time period is t by 2t. Okay, this and this are same, but you are trying to write in the form of function, na? Okay, and function when you function you're writing and you're putting the limit, you're changing the limit in such a way it automatically becomes negative. Okay, sign is negative in this period. So if you want to write in a function, that time you have to take care. Okay, you can't say yes, both are same. Both are same. Yes, this is also positive. This is also positive. But if you put yes sine wave, then this should come like this, because you are now same function you are seeing for different intervals. Okay, if function doesn't change in the interval, it remains the same, then you can put both the same. But here sine in this period, sine is changing the direction. So you cannot represent this function by this function in this interval. You can represent this function by this function in this interval, but you cannot represent this function by this function in this interval. Okay, so you have to put the minus sign because this is the inverse of minus. Okay, that you have to keep in mind. Now you have the output. So this is a full wave rectifier. It is rectifying both the waves. You have the output. Find the average value. Is that point clear to everyone? Okay, that's why I told in the beginning itself I told you what you're supposed to do. Okay, so this is basically not sine. This is a minus Vm sine omega t. Okay, in the interval, given interval t by 2 to t and t. Okay, so please don't confuse because this will be used again and again. Whenever you get like this curve, you put minus here. If you put same like this only, then it is single function. Same throughout the interval. So now find the average value. So if you calculate the average value, okay, V average will come what? Again 1 by t, 0 to t, ft, dt. Okay, so say 1 by t, 0 to t by 2, it is Vm sine omega t plus t by 2 t, it is minus. If you put sine both, then it becomes average becomes 0. But we are not getting 0 average, we are getting some voltage. So average of sine is 0. If you put plus here, then it becomes sine omega t is 0. Sine omega t dt. Solve this one. So this is 1 by T Vm. This we already solved. Vm by pi simple and let it be. So this is your cos minus cos omega t omega 0 to t by 2 plus and this minus again Vm and minus cos omega t omega okay, t by 2 to t okay, and you can take Vm by t common and omega you can write pi by t okay, and this I can change this limit. This will become 1 minus cos 2 pi upon t into t by 2 okay, and minus this I can write t by 2 first. So cos 2 pi by t into t by 2 minus cos 2 pi by t into t okay. So this is your Vm upon 2 pi. This is your minus 1 become 2 minus this become how much t pi cos pi minus 1 and this is what minus t pi is 1 okay. So this Vm upon 2 pi and this become 2 minus 2 4 okay. So this become 2 Vm upon pi. This is the double of double of your half wave rectifier okay. So now based on similar thing one question came in your exam okay, and they ask you what is the average value of output voltage okay. Let us see. So shall I erase this one? किसी को कोई कंफ्यूजन तो नहीं हो रहा ना अभी?
No, sir.
Let us do some problems on half wave rectifier. I am putting a resistance here. Say RS. And I am putting a resistance here. RL. And this is my V input equals to Vm or V naught sin omega t. V naught Vm whatever. Vm sin omega t. Vm sin omega t. And here you are measuring the V load. Okay. Find the average value of VL. Find average value of VL, and this problem came in your exam. Solve it. जैसे बताया है exactly same way you have to do the calculations for positive cycle, for negative cycle. Okay. So, and diode is ideal. Diode is ideal given. So you are basically what you're doing, you are giving a sine wave V input and you can assume that RS is equal to RL. That also you can assume. So first you're applying positive cycle and then you're applying negative cycle. Tell me what's the output. Okay. Now for positive cycle, diode is what? Short circuit. Yes or no? Okay. Diode is short circuit. This. So tell me this whole part is short circuit. Now what is the value of VL? Tell me. How much is the positive cycle?
VL equal to VI हो जाएगा ना.
Very good. Okay, because now, because this is a plus, this is a minus, and this circuit becomes short here. Okay, if it is not, this is not there, then it is circuit in series, but this is becoming short. So no current will pass here, all the current will pass here. So your V load will be exactly equal to your Vm sine omega t for time period of 0 to t by 2. Okay, so this part you will get exactly like this. Okay, tell me for negative cycle what happens. For negative cycle, VL. Negative cycle diode is forward bias or reverse bias? So reverse bias obviously. So this will become open. Okay, this become open. Now tell me what is the value of VL?
RL into Vin divided by RS plus RL.
And RS plus RL is the same. So VL will be what? VL will be exactly V input divided by RS plus RL into RL. Okay. So VI is your VM sine omega t. Sine omega t. Okay. VM sine omega t. And direction also changing. Now this is coming what? Earlier voltage is coming like this. Now if you do this, this is coming like this. Negative is coming. Okay. So VM sine, so RS is equal to R. Okay, and this is 2R. R cancel. So you got VL equals to VM sine omega t by 2. Because now you're measuring voltage, this voltage is coming like this, but you are measuring like this. For you, the voltage is negative. Okay, so you for you voltage is negative, so you're getting exactly like this. So now, so VL is minus not minus, exactly sine wave. If you're putting time period, then it is a sine wave. If you're not putting time period, then it is a negative. Okay, but you put in time period, because without time period you cannot write function. This is t by 2 to t. Okay, you get Vm by 2 sine omega t. Okay, now you have the function, find the average. Tell me what is average coming. Now, you don't have to see this, you have to see this function, and this function is sine omega t only. Only amplitude decreases, so you have to reduce the amplitude. Okay, this is Vm, and this is your second cycle. You are getting half of this one, that is Vm by 2 only. This is your 0, t by 2, t. So this magnitude you have to decrease to half it. Okay, please draw properly.
बस सर मेरा एक जनरल क्वेश्चन था. सर मतलब हम इसमें पॉजिटिव हाफ साइकिल नेगेटिव हाफ साइकिल अप्लाई करते हैं, मतलब इसको कैसे समझ सकते हैं हम?
ये साइकिल आ रहा है, this cycle is coming.
यस सर.
Current is coming like this. Okay, for this, that drop is like this. Anything, current direction. So this cycle is making this diode forward bias. Okay, ये पॉजिटिव है ना, ये ऐसे पॉजिटिव है, ये नेगेटिव है. अगर मैंने कैसे दिखा, you have to check whether the diode is forward bias or reverse bias. Open it. Now if you open this one, positive cycle, this part is plus and no current is flowing, so this is automatically connected to negative. This is negative. This is a forward bias. Okay, so current is coming like this. So current is coming like this. The voltage drop is like this. You are also measuring like this. For you, voltage is positive. Second time, this is positive. This is negative. Current is coming like this, and this sign is positive. This is negative. So this is a reverse bias. We have opened this one. Now current is flowing from here to here. Okay, that means this voltage dividing here and here, but now the battery is like this. Okay, so you are getting voltage like this, but you are measuring voltage like this. So for you, this is the negative. For this is the positive, but for you are measuring opposite. Na? For you,
yes sir.
negative. तो CRO में ऐसा भी आएगा. So now find the average. So for average, V average, V load average 1 by T 0 to T FT PT 1 by T. अब बताओ, तुम करके बताओ कितना आ रहा है. Okay, this VM sin omega T dt plus, okay, plus I am not putting anything now, T by 2, not putting in the minus sign T. This is Vm by 2 sin omega T dt. Tell me what is the answer. How much is coming, Palak?
Sir, 3 Vm by 2 omega.
नहीं. सर पढ़ने का. अबे कैलकुलेशन सही करो. ये तो क्या देगा आपको पता ही है सॉल्व करने पे. What will give? Vm,
Vm by pi.
no, this Vm by omega, okay, is minus cos omega T 0 to T by 2 plus Vm by 2 minus cos omega T by 2 T, okay. So this is 1 by T Vm by omega. I put 0 here. So 1 minus cos 2 pi T by 2 cos pi minus 1 is 2 Vm upon 2 pi. Again I put cos 2 pi T by 2 I'm putting first because I'm observing minus. Cos 2 pi upon T, I'm putting T here. Okay, so this gives me 1 by T Vm by omega. Okay, this one cos pi minus 1, this gives me 2 plus Vm upon 2 pi. Okay, how much this gives me? T by 2 to cos pi minus 1, this one, T 2 pi minus 1 minus 2. Okay, so if you solve this one, how much you get? 1 by T 2 Vm upon omega minus Vm. Okay, and omega also there, na? Here also omega is there. 2 omega. It's not pi omega. Minus Vm upon omega. Yes or no? Okay. Now this gives me 2 pi T upon 2 pi. Or let it be 1 by T is what? Omega upon 2 pi. Okay. And this is how much coming? This is Vm upon omega. Vm upon omega cancel. Vm upon 2 pi is the answer. Check it.
Yes, sir, it's coming.
Okay. So this was your ideal diode. Okay, let me do one more problem, okay, so that you understand properly this concept. Because there diode means we have to see diode for rectifier, diode for clipping clamper, Jenner diode, how works for AC. Okay, we have to make logic gates using diodes. So these applications we are doing one by one. Okay, now the next is your fairing first
आंसर क्या था उसका लास्ट क्वेश्चन
Vm upon 2 pi.
सर
Vm answer na?
ओके सर
Vm upon 2 pi.
यस सर
So you have this V input. Okay. Now please do carefully this problem. If you can do this one, that means you understood the rectifier problem. 10 kilo, this is 10 kilo, and this is 20 kilo. And here one more diode is there. It's connected. This is D1. See, this is D2. Okay, I'm measuring the V naught here. Okay, I'm measuring V naught here. Okay. Find the average of V naught. Find the average of V naught. So for positive cycle, okay, this part is positive, this will be negative. So diode D2 is reverse bias, D1 is forward bias, and D2 is a reverse bias. Yes or no? You can clearly see now. If this point is positive and this is negative, automatically this is reverse bias, this is forward bias. Okay, so you can open this one. For first part, you can open this one, and you can short circuit this one. Okay, so this is basically your circuit. Basically, this part is not there. Now, whatever V naught you are applying, this V naught is going where? Tell me, where it is going? Across which? This V naught is going
सर वो
where?
बीच वाले टर्मिनल्स
इस पे जा रहा पूरा, इस पे तो जा रहा है. Whatever V naught you are applying here, this is what is the equivalent circuit of this one. You are applying directly V input here. Okay, this is your circuit. This plus is coming here. This minus coming here. This is your 10 kilo ohm. Okay, and here you have 10 kilo ohm, and here you have a 20 kilo ohm. Yes or no? This circuit is equivalent or not? Tell me.
Yes, sir.
Because you can just take this one and plug it here. This is removed. This part is removed. So now tell me what is V naught here? What is V naught here? So whatever voltage is coming here, the same voltage is coming across this one, this two part, yes or no? Okay, so you can directly write your V naught. Your V naught is equal to what? V naught is equal to V input, because this V input is coming here directly, and this V input here, this V input. Okay, only dividing in between these two things. So V input divided by 10 kilo ohm plus 20 kilo ohm into I want voltage here. Voltage divider. Yes or no? Okay. Or you can, what you can do, you can find the total resistance, you can do current, and then you can do current division also. Okay. Current division, what the current is coming like here, and current is dividing here and here. So you can do current division and find current voltage, but you can directly do it. That is easy. Okay. And V input is what? V input मैंने क्या दिया है? Vm sin omega t. Okay. That is Vm sin omega t. Vm क्या दिया मैंने? V input is your 6 pi sin omega t. V input is your 6 pi sin omega t given. Okay. So put it here 6 pi sin omega t. Okay. So how much come, tell me? 6 pi sin omega t. Okay, this becomes 30 kilo ohm, and this is 10 kilo ohm. Cancel out. Okay, so you 3. So this comes out 2 pi sin omega t is plus value. Okay, positive, you get positive value. Okay, so that means if I draw my output now, if I draw my output, that is like this, that is my V input, okay, my V output is coming, the way I'm measuring, I'm getting positive. This is coming 6 pi sine omega t, and I'm getting here 2 pi, 6 pi is the maximum value, 6 pi, I'm getting here 2 pi. Okay, I got a function. This is between time period 0 to t by 2. Okay, so I got my V naught equals to 2 pi sine omega t 0 to t by 2. Okay, do it for negative cycle and tell me what will happen. Negative cycle, which diode is forward bias, which is reverse bias? So for negative cycle, this is forward bias and this is reverse bias. This become open. Okay, and now carefully see the circuits. Okay, now current will come from here, this become plus, this come minus, current will come here, this current will come here. Okay, and this current will go here, this current will go here, and the current which is going here will go here. So either you find the total resistance and find the current and you apply current division, or you can see directly from here. How can you visualize the circuit here? Okay, let us visualize the circuit now. How can we visualize? So this is now plus, this is minus, negative cycle. Okay, tell me how to do. So if I see the equivalent circuit, equivalent circuit of this one for negative cycle, I can draw this circuit like, no need to make equivalent circuit. You can directly solve, find the current and apply current division. How much current is coming here? That accordingly voltage will come here. Okay. So, but if you can find easy, then you can do it. Okay. So now this point are same. A negative coming. So I can directly put this 2 kilo resistance here, 20 kilo resistance here. Okay. And this resistance now become 20 kilo here. But this is break here. Okay. This is break here. This is break here. This is break here. So what should I do? This resistance and this resistance again. This is a parallel resistance. Okay. This is a parallel resistance and this is a parallel to this one. 20, 10 plus 10, 10 plus 10. 10 plus 10.
सर ये दोनों सीरीज में होंगे, 10 और 10 सीरीज में होंगे ना?
Yes, 10 or 10 series. 10 and 10 is 10 kilo plus series. Just look at, can I draw like this circuit?
Yes sir.
This point is this point. Okay. So what I did, I just I took this point, okay, and open this one. I just do it like this, okay, so like this, so that it look simple. And now current is coming here. This point is this point. Okay. Again, tell me what is V input, and I am measuring voltage. You have to see I am measuring like this, so I am measuring output like this. Okay, and current is also coming like this, plus minus. Okay, current is also coming like this. So how much is coming? Tell me. V input. This will be divided half and half. So my V naught will be what? My V naught will be half of V input. Now that means half of 6 pi sine omega t, because this 10, 10, 20. Okay, so this is equally dividing, so half. So this will be 3 pi sine omega t. And the sign also didn't change. Sign didn't change. That means this is now 6. Let me draw it here. This was 2 pi. Now I'm getting like this 3 pi. Okay, and this is my input. 6 pi. Okay, so now again same direction is coming, so I have to put a minus sign here. T by 2 to t for this period. So my equations now become V naught equals to 2 pi sine omega t 0 to t by 2, and V naught will be minus 3 pi sine omega t by 2 t. Solve. Tell me the average value. How much will come average?
Sir, I'm getting -1.
Minus 1 average?
Yes, sir.
No. Some mistake may happen. Okay.
Sorry, sir. It should be 5.
5.
Sorry, 5.
5. It will come 5. Okay. Tell me all others are getting 5. I'm not calling. No. Tell me how much is coming. Everybody. Okay. So 2-minute break is here. Tell me the answer. Are you getting 5? Or shall I do the calculation? I think easy. You should get. Joshiba,
Sir,
कितना मिल रहा है?
sir, I'm working, sir.
Directly.
ये सर 5 आ रहा है.
Directly ये half wave rectifier है, ये half wave rectifier. Though ये sum of two half wave rectifier. You can directly can do. Okay. Half wave rectifier will give you Vm by pi. Okay. So this is what 2 pi is half. So 2 pi upon pi give you. So second half cycle. Okay. T by 2 cycle. Into T by 2. Next cycle, this will give you how much? This is also again half wave rectifier. Don't cite in the minus, the half wave rectifier. So this will give you how much? 3 pi 3 pi by pi into T by 2. Okay, and total time is T. So this T cancel, this half, this half. This is not half. Okay, T by 2, T by 2 and T by 2. Yes, should be 2. Na? So how much coming this one? ये यहाँ से कितना आ रहा है? Pi cancel 2. 2. Actually, I'm mistake. T1. This is T by 2. This is 2 pi. Okay. So basically, this is a full wave rectifier, not half wave rectifier. How I put it, half wave rectifier. Okay. So V average will be 1T. Okay. This is 0 to T by 2. Okay. T by 2 you have 2 pi sine omega t. sin omega t plus a by 2t minus 3 pi sin omega t dt. Okay, so 1 by t pi sin omega t cos omega t omega 0 to t by 2 minus 3 pi omega cos omega t t by 2 t. Okay, so 1 by t omega
सर नेगेटिव साइन आएगा.
minus negative right, as well. Okay, so you put negative, that means you 1 minus 1 again will come 1 1 minus 1 2, it will come 2 minus, okay, 2 pi and 4 pi will become 4 pi. 2 will come, if 2 will come from here, minus 3 pi. Okay, and how much will come here from, tell me? Minus 2 will come up from here, minus 2.
Yes sir.
Okay, so how much will come this one? 1 upon t omega, this is
10 पाई हो जाएगा ये.
6 by 10 pi.
Yes sir.
Okay, this 1 t 2 pi upon t to 10 pi. Okay, 5 by 10
5.
5 answer. The calculation is running. Okay, so I'm giving you one homework, simple homework. You have to try and tell me the answer tomorrow. You have plus minus Vs. Here you know 10 ohm exactly like same operator is diode here. Okay, and you are measuring, see right here, and you are measuring V naught here. Okay, now this time your V input or PS is a square wave, not sine wave. A square wave of 10 volts. This is your V input. Can you find average of V naught? Okay, I'm giving you answer also. Answer should come to average of V naught. You're measuring like this. Answer will come 2.5 volt. Okay. This is your first homework. Similar type of one problem I'm giving you more. But okay, have you written this problem?
Yes, sir.
And the second problem I am reversing this. Second problem I am reversing this one, and I'm putting this is a 50 ohm. This is 50 ohm. Okay, and I am giving you a square wave of here 8 volt, and here negative side I'm giving you minus 10. Minus 10 volt. Okay, similar type of question, and the average value answer also I'm giving you. You can find average value of V naught is minus 3 volt. Just note down and send me the homework. क्योंकि यहाँ पे सारे क्वेश्चन मैं कर दूंगा, तो कोई मीनिंग नहीं है. You should also develop some confidence. Okay. So let us do some now next model. Constant voltage, constant voltage drop. Constant.
सर नीचे 8 वोल्ट लिखा है.
ये 8 है और ये -10. Clear na? Constant voltage drop model. Now what is constant voltage drop model? Constant drop voltage model says that if your diode is in the circuit and if diode is forward bias for forward bias, okay, diode is forward bias, okay, and the applied voltage VD is greater than 0.1 for 0.5 for silicon and VD is greater than equal to 0.3 volt, 3 volt for germanium diode, silicon diode and germanium diode. So if in the circuit you have a diode which is forward bias and applied voltage across the diode is coming greater than 0.7 volt, if this is a given silicon diode, so then you can replace this diode by 7.7 volt drop voltage. That means you can replace this diode by a battery, because whenever silicon comes for silicon, this drop is always constant. You say ID versus V, okay, VD. So VD will be become fixed. The voltage drop across diode will become fixed 0.7 volt. That means this is 0.7 volt. So I'm replacing it by battery. Okay, if it is silicon diode, but the condition is it should be forward bias plus VD should be greater than open circuit voltage. VD is basically open circuit voltage across the diode should be greater than 0.7 volt. Okay. Okay, or you say in the bracket you can open circuit voltage, open circuit voltage, open circuit voltage. You have to check. Okay. Now, if it is silicon, silicon will start earlier to germanium, it require less voltage, so it will start here. So basically, now this is your model. For forward bias, you have to replace by battery, and reverse bias is same. Reverse bias is your 0. If it is this voltage is less than this, then also this is a reverse bias, open circuit. Okay. If this greater than this one, then you replace by a battery. Otherwise, even though for forward bias, if voltage is less than 0.7, this will not turn on. So this will be like an open circuit. Okay. And for reverse bias, this is for forward bias. You can replace by this one, and this is the negative part. For reverse bias, okay, for if voltage is here negative, here voltage is positive, you can simply replace it by open circuit. Okay, so the ID will be 0. ID will be 0, and you can replace forward bias diode. Replace diode by open circuit. Replace diode by open circuit. Okay, and here also, if VD is less than 0.7, then diode is open. Then diode is open. Even in the forward bias, VD is less than 0.3 for this is for silicon. That is for germanium. Diode is open. Okay, so that thing you have to keep in mind when you have to replace by battery, when you have to replace by the open circuit. That thing should be keep in mind. The rest I should think is calculation is very easy. Okay, so let us do some problems. Is this point clear? Tell me. If this point is clear.
Yes, sir.
So forward bias, it is a battery for 0.7. Okay, so let us do with one problem, simple problem. I have this 5 volt battery, and then I have a resistance 1 kilo ohm, and then I have a diode, say says the silicon diode. Okay, so again, this is your VR, this is your VD, and the current flowing in the circuit is ID. Okay, so find ID, VR, VD. Fine. So first of all, you have to see whether it is a forward bias or reverse bias, and what is the voltage across this one, whether it is whether it is sufficient or not to make it forward bias, that it should be greater than equal to greater than 0.7 volts, that you have to keep in mind. Okay, so first thing is then you have to check. First, you have to check. For checking, what you'll do, for checking, you will make it open. Diode is open, and this is the 1 kilo ohm. Okay, this is the 5 volt. Okay, what is V open coming here? No current flowing, no drop here. This 5 is exactly coming. So V open is plus 5 volt, greater than 0.7 volt. Okay, diode is forward bias. Diode is forward bias, so you can replace now diode 5 volt. This is 0.7 volt battery. So 1 kilo ohm resistance. Okay. Tell me what is ID value now? What is ID and what is VR and what is VD? So what I can do now, because
So BR 4.3 आ रहा है.
so ID how much come? ID will come this if you write a KVL. Okay, KVL how do you write? Don't forget this -5 plus ID into R. The voltage drop is here, or plus 0.7 equals to 0. So ID will be what? 5 minus 0.7 upon R. Okay, R is 1 kilo ohm. This is 4.3. R is 1 kilo ohm. This is 4.3 milliampere. And VD is how much? VD is how much? Voltage drop across diode is how much?
0.7 volt.
0.7.
0.7.
That is always fixed. 0.7 volt. Remaining VR 5 minus 5 is here. 0.7 remaining will come here. VR will be yours 4.3. It's as simple as. Only in electronics you have to take initiative. Okay. Every circuit is very easy. Yes, you have to believe that what the techniques I have learned I can apply, and you should start applying and properly. Then everything is you can do. So every problem you can solve in the electronics. Okay. So let me do one more problem. So I am doing with this method. You can do you can develop your own strategy because you learn so many techniques. Okay, you can use your own. Okay. Now the next question is, say this is 5 volt. This is the 1 kilo. Let's say this is my diode. Again, I'm giving a silicon diode. Okay. Again, you have to find the same quantities in the circuit. Say this is my VR. Okay. So, and if there is a current, say let us current here. So find ID, VR, and voltage drop across diode. VD. I always define VD like this, from plus to minus.
0.05.
Take it properly. So properly now this is reverse bias. If it make it open, it is reverse bias. Okay, so there is no point of flowing, current is flowing, so it's open this one. So ID will become how much? ID will become your 0. Okay, ID is 0. So VD I've defined. See, define in the question how VD they defined. If VD is defined like this, then it is 5 volt. Okay. But if you have VD, they are measuring like this. Generally, we measure VD with P with respect to N. So VD will be now what? How much? Minus 5 volt. Okay. If minus is there, then only it is reverse bias, na? Are you getting my point? Because reverse bias means this is a minus voltage VD, that's why it's like a reverse bias. So if it defined like this in the question, if they simply ask what is VD, then it is 5 volt. But they ask what is VD, okay, then it is a minus 5 volt. And because current is not flowing, so VR is 0. Clear? Is there anyone who is not getting this one? Okay. Let us do one more problem. So you have to see the polarity, whether is the polarity defined or not defined. If it's not defined, then you can simply say this one.
Sir, your voice is breaking, sir.
Okay. Now is it okay?
No, sir.
Sir, actually there is double wise.
Now is it okay?
Yes, sir.
Yes, sir.
Let us do one more problem. You have. So I am solving here some key circuits here. Okay. Based on this circuits only, other questions will be designed. Okay. So that if you understand this one, the remaining circuits, what are coming in exam, you can do it easily. So I have planned my circuits like this, so that you should not have any problem when you're solving other problems. Okay. So what I am teaching here, you first master those aspects. Okay. And we will see that. Okay. So now this one is your resistance. So this is say 5.6 kilo. It's 5.6 kilo here, and I'm using the V load here. Say VL. This is my RL. Say. Okay. And here current is IL. Okay. So tell me, what is the value of IL and VL? So this is silicon. This requires 0.7, and this germanium, both are in series. This require how much? 0.3. Total they both require how much? If I see, if I make it this circuit open, and if I check how much open terminal voltage is coming, okay, and then I put a diode, then whether the diode will conduct or not conduct, okay, that we have to see. So let us make it open. This is open. Okay, this is open. Okay. Now tell me whether how much voltage, total voltage coming here with respect to here and here. How much voltage is coming? So obviously no current flow. So all voltage 12 volt will come here. So between now these two terminals you have to see whether between these two terminals the voltage is greater than 1 volt or not. If it's greater than 1 volt, that means these both diode will conduct because both are in series. Okay, if one is conducting, other is open, then current cannot flow. So both has to conduct. That means this open circuit voltage, this voltage should be greater than 1 volt. And so it's greater than 1 volt. So both will conduct. So this will be replaced by 0.7 and 0.3. This becomes 0.3 volt. This becomes 0.7 volt. Now you can find what is IL. Okay. So you can again write the KVL here. KVL is what? Minus 12, then this plus 0.7, plus 0.3, and then you have a plus VL plus VL equals to 0, and VL is what? IL RL, directly you can write VL 0. This plus minus VL if you're writing voltage. So VL will be what? VL will be 12 minus 1, that is 11 volt. And if you want IL will be VL upon RL, 11 upon 5.6 kilo ohm. Okay, tell me how much is coming. It should come 1.96 milliamperes. So this problem tackles when the diode in series. What happens if diode are in parallel? Okay, let's see that one. So now put a silicon diode and germanium diode in parallel and apply some 10 volt there, and let us see what happens there. So now the same circuit, I'm erasing this one. Okay, same circuit I'm using now, similar type of circuit. Okay, this time I am applying 10, this is 10 volt. This is my, say, silicon diode, and this time this is my germanium diode. Okay, all are connected like this. Okay, and then if they are conducting, okay, so let us see. I want to find this one. I'll change the problem. I want to find what is V output here. Okay, tell me what will be the V output.
0.3.
Let it put resistance here. Let it put resistance here. Let it put resistance here. Okay, and this resistance is 100 kilo ohm. Now tell me, what is the V output?
0.3.
0.3 आएगा सर, क्योंकि
See, now both cannot turn on. Okay, because if it is get turned on, this becomes 0.7. If this get turned on, this becomes 0.3. Okay, so either here voltage can be 0.3 or 0.7. Both cannot be there, na? You cannot say this is 0.7 and this is 0.3. 0.3 and 0.7. Two voltage cannot come here. So which which require lesser voltage? That diode will turn on. Okay, always remember, whenever they are parallel combination, okay, which diode has required less voltage, that will get turned on, and this will remain open. This will come 0.3 volt here. So your V0 will become 0.3 volt here. Okay, now you can find what is I. Okay, I in the circuit will be what? I will be circuit at 10, 0.3 here, 10 minus 0.3 divided by 100 kilo ohm, that is 9.7 and 100 kilo ohm. Okay, how much will come? Tell me. 10 raised to power 5, 9.7 to 10 raised to power 5 ohm. Okay, or 97 microampere. Okay, ampere, 97 microampere. If this point is clear to everyone or not, what I said now?
yes sir.
If two parallel branches there of diodes, okay, so the branch here, maybe one resistor also there. Okay, I can put the resistor also here also. The branch where you require less voltage, okay, that will turn on first. Okay, that you keep in mind. Suppose if I put a resistance here, this resistance, suppose if I put here, well, let it be, this is also be here. What is the issue? This is also here. Okay, then you have to see whether this here diode is there, and here also diode is there. This is germanium, this is silicon. Okay, then you have to see which can start first. This requires 0.3. Even if you go 0.4, this will start and current start flowing. So this will start first. This will remain open. Okay, we'll solve that problems later. Okay, so let me give one more problem. So say you have one diode here, and then you have a 2 kilo ohm resistance here, and this is your plus minus 2 volt, and here 6 kilo ohm resistance here. Okay. Now this diode find this current I, find I. Okay. In 3 cases. First case, diode is made of silicon. Diode is silicon. Second case, diode is germanium, and third thing, diode is ideal. Okay. All the 3 cases you find I. And this is a very nice question. If you understand this question, it will be great. Okay. Then you can later you can catch up very easily. So first case first, you say my diode is silicon. Very good. Okay. Now you tell me whether diode is forward bias or reverse bias. Diode is open or conducting. Okay. Find
Conducting diode.
conducting. Find whether silicon diode is conducting or not. Is conducting or not. हाँ, conduct कर रहा नहीं कर रहा है. Joshiba, Sachin Singh, and Ujjwal, how to find whether diode is conducting or not conducting? How to
चेक
find?
उसके अक्रॉस नेट वोल्टेज चेक करना
सर इसको
पड़ेगा.
रिमूव कर देंगे, डायोड रिमूव कर देंगे पहले।
हाँ, रिमूव करके बताओ ओपन सर्किट वोल्टेज कितना आ रहा है, whether it is sufficient to conduct or not.
जो 2 किलो ओम के अक्रॉस आएगा वही इसका cross।
हाँ, जो 2 किलो ओम का आएगा, तो what is the voltage across 2 kilo ohm? Voltage across 2 kilo ohm is how much coming? Make it open. First you have to check. So this total
2
voltage
upon 2 plus 6
2 plus
2
6.
plus 6
0.5 आ रहा है सर, अक्रॉस पूरा सबट्रैक्ट करके.
तो कितना आ रहा है? This is 4 upon 8, that is 1 upon 2, that is 0.5 volt,
यस सर, 0.5 आ रहा है.
less than 0.7 volt. So silicon is not conducting. Silicon diode is not conducting. Diode is not conducting.
ओपन सर्किट हो जाएगा फिर.
Open circuit. Now you can tell me what is I. So I will be simply 2 divided by 8. It is 0.25 milliampere.
अच्छा क्वेश्चन था ये.
Milliampere. Okay. Now the second case, निशांत और कौन है? सबना पढ़ने is there?
Yes, sir.
Now second case, tell me whether germanium diode will be on or off.
On, sir.
ऑन होगा सर.
On कर दो. Case second. Case second. Germanium diode is on. Okay, because V open is greater than 0.3 volt. Okay, because we found V open of diode. V open was 0.5 volt. So on means this is a now short circuit. Tell me I will be how much? Not short circuit. Germanium means 0.3 volt.
0.3 is
0.3 volt for germanium. Okay. So now you can find what is I. So now if this is 0.3 volt, this is also 0.3 volt. Yes or no? Both are parallel. Okay. So I will be what? 2 in this loop. 2 minus 0.3 divided by 6 kilo ohm. Okay, this become how much? 1.7 divided by 6 to 10 raised to power 3. Tell me how much is coming. 0.02. How much? कितना आ रहा है? Point. How much milliampere? 2.8 milliampere आ रहा है क्या? Check it.
सर 2.833
3 milliampere. Okay, 2.83 milliampere. Okay, and now case number. So this is this I. You can find I here also. Okay, this is I. You can find I here also because you know voltage, you know resistance. Okay, so you know this I, you know this I. You can also find how much ID is flowing. Find ID also in this case. How much is ID from germanium? I germanium. Find I germanium. Okay, so I germanium is basically what? I germanium is basically total I, that
voltage
is 6
drop
kilo ohm minus
2 kilo.
I across 2 kilo ohm. Because these two current will only make this I germanium is I 2 kilo ohm, I 2 kilo ohm. This two will only make this current. Okay, so I 2 kilo ohm. So I6 is 2.83 milliampere. Okay, milliampere or ampere, and minus 2 kilo ohm में current, how much current is there? I 2 kilo ohm, how much there? I 2 kilo ohm is your 0.3.
इसका करंट इसमें डिस्ट्रीब्यूट हो रहा है.
So this is how much gram? Tell me. 10 raised to power 4, 1.5 to 10 raised to power minus 4, that is 0.15 milliampere. Subtract this one and this will come around how much? Around 2.83 में से 15 गया कितना आएगा? 68.
2.68.
2.68 10 raised to power minus 3, 2.68 milliampere. Okay. And first case, when diode was open, the I silicon was 0. Okay. First case, I silicon was 0. Now you can take last case when this is the ideal case, and tell me how much the voltage will come. Okay, the last case, diode is ideal. Okay, ideal means it will be replaced by short circuit. Okay, if it's short circuit, that means there will be no current flowing throughout 2 kilo ohm. Here no current will flowing. So whatever current is coming here, okay, that will current here. So this is short circuit. That means this is not there. Now this coming. So now I will be simply 2 voltage across 6 kilo ohm. 2 divided by 6, that is current will be how much?
333 milliampere.
0.33 है. ठीक है. Okay. 0.33 ampere. 0.33 ampere or 3.33 milliampere. No, 33 milliampere. That's 33. 33 milliampere.
Milliampere, yes, sir.
33.33. Yeah. Whatever. Check कर लेना.
यही आ रहा है.
Ampere. Okay. So this was your time is remaining. Shall I continue 10 minutes more or it's okay? I can stop.
Sir, can you repeat the ideal diode alone once?
So ideal diode, what is the case? Ideal diode, this becomes short circuit. Okay. Because
Okay,
the
sir.
voltage is greater than so ideal diode does not require any voltage, na? Only it should have a forward bias. So it was forward bias, it becomes short circuit. Now if current will come, say I. Okay, here no current will go because all the current will go here, and this current will come here directly. Okay, so this current and this current are same. So this voltage, because here this is a short circuit, so it will be short circuit. So voltage, this whole voltage will be divided across the 6 kilo ohm only. Okay.
Okay, sir. Thank
So
you, sir.
2 divided by 6, you can find like this. Okay. Okay, now let us do one more problem, and then tomorrow we'll continue. Tomorrow we'll continue next model, piecewise linear model. Okay. Say I am giving you this one. You have a resistance here. Here you have a 1 kilo ohm, and here you have a diode. Here this is a plus minus 2 volt. Okay, and this is grounded, and here is a 1 kilo ohm. And I'm applying now, say input V input here, with respect to ground, and V input is 5 sin omega t. This is given in the question. Okay, so maximum value is 5 coming here. So you tell me V output. Okay, find the maximum, and you are measuring V output here. Okay, find maximum and minimum value of V naught. Okay, diode you can take as silicon. Diode you can take silicon. Okay, now solve it. Tell me how it will come. What is the V out, V max and V low? Okay, or simply don't say V max and V low. I'm just giving you an input here. Say I'm giving you input here like this. Okay, this is 5. You tell me the output. What is the output is coming? Okay, tell me what is the output will come. So for that, first of all, again, you have to see this diode can conduct only when
इसका वोल्टेज ज्यादा होगा.
ज़्यादा हो. Okay, when V input is greater than this one. Okay, so if V input is greater than whenever V input is greater than 2 volt. Yes or no? If it is,
Yes, sir.
it should be greater than 2 volt. Okay, this combined, if it is greater than 2 volt, then only this diode can be forward bias. Okay, and once it is become forward bias, automatically this voltage become, and this becomes 0.7. Okay, now if this is 0.7, tell me how much V naught will come. So initially there is no current is flowing. Initially, if this diode is reverse bias, no current is flowing. So for up to this cycle, you won't get any current. Okay, you won't get any voltage up to this one, because up to this one, this diode is reverse bias, so open, no current is flowing, so no voltage. No, if it is open, tell me what will happen. If it is open like this. Okay, so obviously this gone out of the circuit. This gone out of the circuit. Okay, and here also no voltage drops, so you exactly get whatever is there. You get exactly what is coming here, because you are directly measuring out this point with respect to ground. Okay, so you exactly what you're getting, that will come exactly same like this. Okay, this will come like this. Okay, now tell me what will happen when it is conducting. So when it is conducting, this becomes 0.7. Okay, now let us find the value, maximum value. Okay, so now here is coming, say 5. Okay, maximum value I'm calculating. So this is -5. Okay, because it's a sine wave. This is a plus, this is a minus. So -5 plus 2 kilo ohm. Okay, 2 kilo ohm is how much? 2 into 10 to the power 3 kilo ohm
10 to the power 3.
into I current is coming, say I current is coming here, and this is 0.7, this become 2.7, total 2.7 volt equals to 0. So this will give me I how much? I will come 5 minus 2.7, 2 into 10 raised to power 3. Okay. And what will become? This will go divide 4.3 divided by 2. How much is coming? Tell me. How much is coming? Solving.
सर वो 2.3 आएगा, 2.3 ऊपर.
2.3. How much is the total?
नहीं नहीं, आगे घटाने के बाद 4.3 की जगह 2.3 आ गई, ये बोल रहा हूँ.
This is 2.7 na? 2.7 and this will come
2.3
how much coming?
अपॉन 2. तो ये 1.15 मिली एम्पियर आ रहा है. 1.15 मिली एम्पियर.
1.15 milliampere. Okay.
Yes, sir.
So this current is flowing
ये
here.
क्या किया सर ने?
This, see, this is your 5 volt. I am taking maximum value of this one. Okay. Maximum value of when this is when this is greater than 2 volts. 2 volt, this will start conducting na. This will start conducting. So if voltage is more, obviously the current will be more. So voltage will be more here. Okay. So positive cycle, how much is the maximum value that I'm calculating? So you got the current here. This current is flowing here. So how much voltage drop will be here? 1.15. Yes or no?
I into R कर देंगे.
I into R 1.55. तो मिली एम्पियर 1 किलो से कैंसिल हो जाएगा. तो
1.15 वोल्ट हो जाएगा.
तो ये कितना हो जाएगा? 2 तो ये टोटल कितना हो जाएगा? 1.15 and this 2.7. How much will come? 3.15. 2.7 and 1.15. How much will come? 5. This come 8.
3.85 हो जाएगा. 3.85.
3.85. So whenever it start conducting, so अब ये plot नहीं कर सकते because I only take the maximum value ना. See, if it is a 3 volt, then current is different. If it is a 4 volt, the current is different. If it is a 5 volt, the current is different. Okay, so this will change. But what they are asking what the maximum value. Okay, so we cannot plot like this graph. Okay, so they are asking maximum value. So V max, okay, of output, that is V output max or positive circuit may it will come 3.85 volt. Okay, if it is not clear, please tell me. I'll repeat again. Student, if it's not clear, I'll repeat again. Tell me. Is it clear?
Clear, sir.
So either you can understand this problem in this way. Okay.
सर इसमें मिनिमम कितना था, मिनिमम आउटपुट?
बता रहे हैं. अभी first we are solving for positive cycle. For positive
Yes,
cycle,
sir.
okay, you can say this is maximum value is 5 volt. Okay, and say this is my V naught. Okay, so I want to find what is my V naught when this is maximum. So this come 5 minus V naught upon 1 kilo ohm. This current will be equal to what one? This will be equal to V naught. This V naught, okay, minus this 0.7, 2.7 divided by this 1 kilo ohm. Okay, so you correct, na? And now you find what is the value of V naught, is how much coming? Tell me whether I'm doing correct or right or wrong. It's correct only. So if you solve this one, how much will come?
सर हमने क्या किया, मैं समझ में नहीं आया. हमने क्या किया इसके अंदर ये?
This is 5 minus
Yes, sir.
Y naught divided by this 1 kilo ohm. This is the current.
इक्वल टू. ओके अपन करंट इक्वल किया है. क्लियर, ठीक है.
This current is coming V naught minus 2.7 and this one same current is coming here. Okay, so now this cancel out. Okay, this 5 minus V naught minus 2.7. Okay, this has become 2 V naught equals to 2.7. How much is coming? Tell me. 5.2.7 upon 2. Same will come 3.3.
सेम यार.
Okay, so that is same. So this is easy to understand. That's why I repeat it again one more time. Okay. Now for negative cycle, tell me what will happen. Negative cycle. So this is a positive cycle, maximum value 3.5 volt. Okay, positive cycle. Now for negative cycle. For negative cycle. So negative cycle, this max is minus 5 volt. Okay, this is 0. So negative cycle, this is open. So whatever voltage you are applying, that voltage will come here. Okay, so if you apply -1, minus will come -2, -2, -3, -3 come. So your V max, V output max, okay, that will come negative cycle. For negative cycle, for negative cycle -5 volt. Okay, and that we are telling minimum value, because in the question they're asking positive value maximum and still minimum. So this is your answer. I hope the question is clear.
सर सर नेगेटिव हाफ साइकिल में तो लोड में कुछ आ ही नहीं रहा है ना, फिर तो जीरो ही हो गया ना। नेगेटिव साइकिल आ रहा है तो यहाँ तो पूरा
नेगेटिव में
पूरा
करंट
ओपन हो गया ना,
हो गया, ये ओपन हो गया, ये हट
पूरा
गया,
ओपन हो गया।
हो गया। अब जो वोल्टेज यहाँ आ रहा है वो तो यहाँ आ रहा है, इसमें करंट फ्लो नहीं हो रहा है, ड्रॉप नहीं हो रहा है।
यस सर।
जो वोल्टेज यहाँ पर है वो तो यहाँ आ रहा है, वोल्टेज तो लगा हुआ है, ड्रॉप नहीं हो रहा है। सोर्स इज देयर but current is not there, so this drop is not there, this same voltage is actually coming here,
यस सर।
so it is -5 volt. So maximum asking minimum, maximum -1 is there, -1, -2, -3, -1. Okay, it will come. Okay, so this type of questions we'll do more. Okay, so I'll stop here today and we'll continue tomorrow, because बहुत सारा चीज एक साथ हो जाएगा तो फिर तुम लोगों को गड़बड़ हो जाएगा. Okay, just let's stop here. Thank you.
थैंक यू
Thank
सर।
you, sir.